All right, in this video, I'm going to be proving the quotient rule for you. And this time I'm going to be proving it using implicit differentiation. A lot like I proved the product rule again using implicit differentiation. Okay, if you've watched these proofs along the way, you saw I've already proven the quotient rule for you using algebra and the definition of the derivative, and it was kind of a lot. It was, mainly hinged on getting something with a common denominator and factoring out the right thing and maybe adding a clever form of 0 or something. It wasn't that great, right? This, I think, will be a lot cleaner. I think you'll like it more. So, again, much like with the product rule, I'm just going to let y equal f divided by g, where y, f, and g are all functions of x. Okay? That means that, well, g times y is going to equal to f. And then I can take the derivative of both sides of this equation with respect to x, right? Okay. And fortunately, I just proved the product rule for you, so you know that that's true. You know that I can take the derivative of this by calling it g prime y plus g y prime. Okay? And that's going to be equal to the derivative of f with respect to x, seems like f prime. And then, well, it's pretty much all over from here. I just got to solve for y prime, right? Because I'm trying to show what is the derivative of f divided by g, so I just got to solve for this thing. So y prime, I'm going to get at that by subtracting g prime y. Right? And then dividing by g. Yeah. And then the idea is, well, what is y? Hold on, why is this? What's happening here? Y is equal to f times g. No, y is equal to f divided by g. And so, oh, I see what's going to happen. Yeah, I'm going to need to come up over here. So y prime is going to be f prime minus g prime times y is, well, f divided by g. And, well, ideally, I would want this to be, like a common denominator situation. So what I'm going to do is I'm going to take this, I'm going to multiply it by g divided by g. Okay, so f prime g divided by g. And then, you could factor out the 1 over g and then include it in the denominator and say that now I've got y prime equaling f prime g minus g prime f divided by g squared, which is what I hoped to show in the first place. And that's the quotient rule. And this was much, much nicer, right? Much nicer than what I did before.